Welcome to the Glassworking shop. In this video, I'm going to continue development of my new chip stack assembly system using a small high temperature kiln and an apparatus that I'm currently designing and constructing and prototyping to slide a ceramic plate with the chips on it, slide that plate into the kiln, heat the chips to reasonable working temperature. I still haven't figured out exactly what working temperature to use, and then pull the plate out and using a hand torch and graphite tools kind of squish the pieces together and get them all to fuse. I don't believe it's going to be possible or reasonable to do it entirely in the kiln, basically just put the pieces in and let them melt together with no assistance. I think that's not going to work correctly, but who knows, it's a research project. So let me go over to the other side of the shop and kind of give a little overview of what's going on. This is a Paragon Caldera ceramic kiln that is rated for operation up to 2400 degrees F. I'm not using it at that high temperature. For this experiment, I'm going to be heating to 1700. But like I said, it's a research project, and we'll see how it goes. So I built this mechanism with a foot-operated lifter, and then a kind of like a little forklifty kind of thing that can, looks like I'm going to have to adjust that can put the ceramic plate into the kiln for heating, and then when it reaches proper temperature, go in, grab it, and then bring it out. And got a bit of an adjustment problem here, but hey, that's the world of R&D. I've got some insulating, ceramic insulating blocks down here, kind of somewhat crudely mounted to try to prevent some of the heat loss off the bottom of this thing when it comes out. Then I'm going to use a GTT Mirage hand torch together with some graphite tools to kind of squish the pieces together and hope they don't stick too bad to the ceramic plate. In the first experiments that I did, I used a regular El Cheapo kiln shelf. At first I tried it just regular, just as it came, and the glass stuck to it. I mean, stuck but good, I tell you, and I'll tell you again, it stuck way too good. So then I tried kiln wash, and that kind of worked. It's messy, it leaves residue. I had to grind the residue off the chips. Some of it actually penetrated quite deeply into the glass, so I didn't really like that. Now I'm using an experiment here. This is a 99% alumina high temperature ceramic plate that I've sanded with 1500 grit sandpaper to try to make the surface super smooth. It's an outrageously expensive material, and fortunately I can afford to spend money on silly stuff like this. The ceramic world is rather complex. Most of the ceramic companies, their website basically says, contact our engineering staff for a quote on your custom project. This was one of the few that I could find in stock, and we'll see how it goes. This will be the first time it's used, and we'll see if maybe it works well. So anyway, I've got a close-up photograph showing the chips that I'm going to be putting together. The pull, when I made these chips, the pull didn't come out as well as I would have liked. I'm still learning this stuff. I'm nowhere near a master yet. And some of the better chips have already been fused together, and this is kind of like the tail end where I'm using kind of like whatever fits, and they're kind of not the same size, and they're not all square, and they're not that good, and they have holes in them. And anyway, I'm just going to see, this is part of the experiment, to see if maybe with this process I can kind of like salvage some less than good chips and see if I can get something approaching a decent result. So I'm going to open the guy up. I always start from cold when doing this process. I'm going to get the guy in here. I'm going to have to adjust this. It's a bit of a problem, but I'll adjust this before I continue the video. And then lower the kiln down, flip it on, wait for what seems like forever for this Paragon controller to actually complete its power on sequence. It's really weird. It's like the scut comes on instantly, and the Paragon you have to wait and then push a whole bunch of buttons. And okay, now we're going. I'm going to wait for it to come up to temperature, turn off the camera, and continue in an hour or so. Okay, we're up to temperature. Get the hand torch ready. So we're at 1700 degrees in the little Paragon Caldera kiln. I've got my tools ready, I've got my hand torch ready, and let's see if we can make this pig oink. So, and there they come. Well, that's interesting. I'm getting a little bit of fire from the supposed ceramic insulator plate. So that's good. It didn't stick. And I've got them fused together barely enough now that I can kind of push them around. The substrate plate here is stainless steel, which is, I think, a reasonable choice for a substrate, although everything about this is still under development. Got a lot of squeezing together to do here. A lot of the joints are really open. I made a special custom graphite paddle with a top reinforcement that you can use. It's interesting, this ceramic fiber insulation material claims to be rated to like 3,000 degrees, but when I hit it with the torch, it flames. Oh, the joys of R&D. So far it appears that my high temperature ceramic is behaving very nicely. I've got no sticking whatsoever on the very smooth surface. Radiant heat is getting to be a tiny bit annoying, and I may, as I continue the process, I may go and get my TIG glove. But the glass appears to be very nice and soft, possibly even too soft at times. which is good because I like it when it's soft. My previous attempts at doing chip stack assembly on a plate were done on a graphite plate that was heated in a normal annealing kiln at normal annealing temperature, and it worked, but tended to kind of suck all the heat out of the chips and made it very easy to severely overheat them, causing the surface to boil. Of course, in all the work I'm doing, I'm constantly fighting boiling and bubbles, and I'm not sure if I'll ever find the perfect solution for that, other than just being careful. But this seems to be working very, very well. So now I'm going to flip it, and the bottom side is totally free. When I use the kiln wash, the bottom side came up completely covered with really annoying dust. So I'm very surprised that this so-called insulating material, maybe, who knows, maybe if I just hit the whole thing with a torch and burn away the top layer, once it gets past that, there may be some sort of a flammable binder or something in this, but never used it before. That's all part of R&D. So unfortunately, the Paragon caldera takes a pretty long time to recover. If I continue developing this process, I may look into either upgrading the kiln, or if I really wanted to get crazy, making one from scratch. I'm not sure I want to get that crazy, but when I put the plate back in after it's cooled, the kiln drops down, and then it looks like it's displaying an error message, so got a bit more mystery here. I don't know if it was unhappy about being opened or what the error message means, but hey, that's R&D. So when it gets back up to temperature, I will turn the camera back on and continue the process. Okay, we're back up to temperature again. Get that torch going. Okay, here we go. Still not sticking, which is a very, very good thing. Gently torching, being very careful to avoid overheating and boiling. At least I'm trying my best. As the project continues, I'll probably experiment with different temperatures. I've already found out that if I get the glass too hot, it sticks. But who knows, maybe there's some combination of temperature and surface preparation and still not sticking. At the edges where the glass is, where the glass needs to fuse at the edges, it tends to kind of curl up, ball up, and not want to stick together. So what I'm doing is just pressing it down into a flat surface, and then as I reheat it, I'm able to even it out. But the nature of glass, the tendency of the material, is to kind of like round up at the edges. Trying to get the far edges to fuse together is a bit of a challenge, because even though the ceramic plate just came out of the kiln, as soon as it is exposed to ambient air, the surface cools really rapidly. I may experiment. I designed this fixture with open area below the working surface, and I may experiment with putting a Bunsen down there to try to prevent some of the heat loss. The sound you may hear in the background is the oxygen system starting up. I stopped using tanked oxygen a while ago and built a very useful DIY oxygen system with both high pressure and low pressure compressors. The high pressure compressors are home fills. I have 2 of them. The low pressure is a typical California Air Tools oil-free piston type, or actually diaphragm type compressor. So now that I have it fused, I'm gonna try to get it flat so that there's less to grind away in the cold working process. The problem with using the graphite paddle to try to close up the open joints is that it tends to make a divot, a low spot where the paddle is applied, and I think part of that may just be lack of skill on my part. But after the gaps are closed, and I did notice there were some holes in the chips, and they have now been closed. So now I can concentrate on trying to refine the shape. And it is, when I push it from the sides, I can feel that the chip stack is actually very, very soft. and it doesn't take much force at all to deform it, so I have to be very, very, very gentle in my touch. In my previous design, where I used the graphite plate as a chip stack fixture, it never got this soft. So that's looking really good. I'm gonna flip it over another time. Back into the kiln. Take a look, 1625, not displaying the error message, dropping down 16, 1590, 1580, 1580, 1570, dropping quick. It'll drop down to about 1530 or 1550, 1530 now. No, 15, it's flashing by with the time and temperature back and forth, so 1548, 45. Okay, we're back up to temperature again. The little bit of mystery fire that I had from the ceramic block here seems to have, the various different blackened areas seems to have burned away, revealing a clean white area. So it probably was just a flammable binder holding the ceramic together, and after it gets hot it turns white and it's just fine. So all is well. Back up to temperature. I'm going to continue flattening, refining, working the edges, and trying to figure out how much is enough and how much is too much, because these things are already pretty well fused together, and obviously every time I put the flame on the glass I'm risking bubbling and scuzzing and all the other things that happen when you hit glass with flame. Now this is my special custom-made graphite paddle with a reinforcement on it, a welded steel reinforcement, so I can apply pretty significant downward pressure. Of course, if I wanted to really get crazy, I could have a press assembly mounted to the apparatus, but I don't want to get that crazy. Come on. When does it all end? I'm going to try to see if I can refine these little ends a little bit with a very fine flame. Get them all to stick together without undue trauma to the glass. One strategy I'm imagining, and I may do this the next time I do this, is to make a kind of a sacrificial border instead of trying to get the fused outer edges to be really nice. Maybe have like a border of black all the way around. Just cut up some pieces of color rod and kind of roughly flatten them out, kind of, sort of, and make a sacrificial border so I don't have to spend so much time dicking around with these little end joints, which are the most troublesome in this entire process, are the end joints, because they just never seem to get hot enough. And even though I'm using the highly focused lynx flame with a nice amount of blue knob, they still just don't want to close up as nicely as I'd like them to. But there are so many questions that need to be answered in the development of a process like this. And of course, I speak in terms of development of a process. It's a development of a process for me because it's the first time I've done it. Who knows, maybe there's somebody out there in Glassland who goes, dude, I've been doing this for 20 years. You don't even know, you don't have any idea what you're doing. Okay, that's looking pretty good. It's always a question of how good am I going to try to get it before I just call it good enough. I've never yet made a bubble-free marine stack of course. Most of the bubbles are minor and not super objectionable, and you almost have to look at them under a microscope with the right lighting to even know they exist. But still, I'm attempting to develop a process and find out how perfect can I get it? What are the limits of this process? Can I ever make a completely bubble-free stack? Haven't done it yet, but doesn't mean I'm not trying. So, I'm gonna flip this pig one more time. Back into the little kiln. Watch the temperature drop. 1620, 1610, 1600. The controller may just be going into an error state because it gets confused. It's got the heating element turned on and the temperature is dropping. And so, who knows? Maybe I'll just deal with it like it is. Maybe I'll build my own kiln. Maybe I'll build my own controller. I am capable of such things. But hard to really know when to stop. How much is, there we go. It kind of turns itself off when I insert the cold plate. The controller thinks, oh, there's something wrong, and goes into an error state because it has the element on and yet it's losing temperature. So Who knows, maybe I'll just stand there and push the button and correct it, but it's also possible, and I'm not sure if it's worth doing, but it's also possible to imagine using a more traditional glassworking kiln. Since I switched to my Scott, I've got a leftover F-130 that conceivably could be retrofitted into this apparatus. I like saying it with a fake accent like that, apparatus. Conceivably that might work, but this seemed like a good idea at the time, and other than the long time it takes to wait for recovery, seems to be working. So turn the camera off and see you later. While I'm waiting for the last few degrees of kiln recovery, I thought I'd say a couple of words about my overall design philosophy, and more importantly, my philosophy of sharing and intellectual property. Everything I invent is open source. Everything I invent is freely shared. There is no intellectual property. I don't patent my ideas. And if this project turns out to be successful, it's probably impractical for me to offer it for sale. So I really can't imagine offering this apparatus for sale, although, you know, never say never. I will probably publish a complete set of drawings and assist anyone who wants to make one. And if there are, one or two special machined parts that's outside of the ability of a normal metal fabricator to make, I may offer those for sale. But in general, I'm in this for the adventure. I'm not in it to make money, and I strongly believe that sharing is good. So I'm going to go back over here and get back to work. I think temperature has been recovered again. Going to do one more final shaping, and then it's off to the kiln for annealing. And then I'm going to inspect it before I do anything. I'll probably end up cold working it and rolling it up, seeing if I can successfully complete a roll-up and vacuum sleeve, which is something I've been working on. Another historical note, the first one of these that I made had a plate, a metal plate that slid into the kiln, and while I was designing it, I was somewhat skeptical. I was thinking, is this a good idea? But a lot of my designs I just do with intuition. I don't have software for heat flow analysis, and don't have the interest, the motivation to try to figure out how to do it by hand. And so I just kind of like build them and test them, build prototypes and test prototypes. Turned out that the metallic substrate totally sucked all the heat out of the kiln. Never got even close to up to temperature. So the new design has a kind of a, similar to what the hot shop guys do with their handheld fork when they put their pastorelli into the glory hole, except this is optimized for the small scale single person use. And who knows, if I get crazy, I'll put ball screws or servo motors, stepper motors on the axes and have it all one button, just like, okay, take it out, push the button, thing opens up and it comes out. Or maybe not. Maybe I'll do something else, I don't know. But anyway, it's an ongoing project. This is the third chip assembly that I've successfully completed after a couple of initial catastrophic failures, and I kind of thought I'd wait until I was somewhat good at it before doing videos. Although, from a strictly educational perspective, maybe watching me fumble and fail might be useful to somebody. So anyway, here goes. Last and final shaping. The surface actually looks really, really good. I don't see any sign of boiling, bubbling, anything that looks bad. When I was doing it before on the graphite plate, I sometimes noticed that while I was trying to compensate for the loss of heat through the plate, I was overheating the surface and seeing signs of boiling, signs of degradation. So far it looks really, really good. So I'm going to be going into the kiln now, into the annealing kiln, kind of like preheating my tweezer so I don't shock the thing too bad. No signs of sticking on the ceramic plate, which I'm very happy about. So, into the kiln it goes, and thank you for watching. For anybody who's interested in the progress of my inventing procedures and just watching as I develop my glassworking skills along with developing my machines. If you find that interesting, well, I'm glad I make the videos for you. So, once again, thank you for watching. It's been fun, and I think I'm making progress.